Welcome. Today's video should be pretty quick. It's all about how we measure forces, and it's pretty simple, pretty straightforward. Very similar to maybe something you've used in the past. So real quickly, how do we measure forces? Well, the first thing that we want to remember is that we need to use an object called a spring scale. And so let me make sure, there we go, perfect. Spring scale. And so I'm going to show you an image of a spring scale and the major parts of it so that it helps you to understand how we use them. Well, first, there's two words right there, spring and scale, and so the spring part is this part right here, and it's hard to see it because the spring is all collapsed, but that's a very thin gauge spring right there. And then there's the scale down here, and you can see that there's an N right there, and then it goes down from 0 down to 1. And so we're going to talk about what that means in just a second. You may also notice that there's a red, kind of a larger red piece right there, part of this plunger. That larger red piece is where we measure it. There's a hook down here at the bottom, and if you pull on that hook, it'll pull this whole red piece down with it, and it'll stretch out this spring. And last but not least, that red piece is called the plunger, of course. And then the last but not least, sometimes the springs get a little out of joint there. And so we sometimes need to calibrate our device, our spring scale, so that we make sure that this top of this plunger right there is right at the 0 line. You can see it's not right now. So when you hang it, you'd want to make sure before you used it that the plunger was reading right at 0 with no weights on it. And the way that you calibrate that is through this calibration screw at the top here. That's it. That's all there is to it. So we use a spring scale. We hang it the spring scale like so usually, or occasionally, and I didn't draw this out, but one of the other things that we'll do with it is we'll take a device like a box that has a hook on the end, and we will hook the spring scale to the end, and then we will apply a force in that way right there, like so. And so the spring scale will measure out how much force we're applying, like so, or it will measure the weight of the object if we hang it from a ring stand like that. Again, we read it where the plunger is, so we have to look for the top of the plunger, and then wherever the top of the plunger is, let's say it's right here, then we'd look across on the scale to see that that's 0.5 N right there. So what does that N stand for? Well, in the United States, we typically measure forces in pounds, right? So if you go to the doctor, your doctor asks you how much you weigh, you can report that out in pounds. Weight is a gravitational force, right? So you can actually measure any force in pounds in the United States. If it's not a weight, then we typically call it a pound force. Is kind of a weird unit, but that's typically what you do, and some engineers do that. But in the MKS system, this is meters, kilograms, and seconds, which we use in physics, forces are measured in this unit called newtons. And of course, it's named after Isaac Newton, and it's the metric unit of force. And so we'll talk about more when we get to Newton's second law, what exactly a newton is actually composed of. But for now, it's kind of interesting to know that 1 pound is the equivalent roughly of 4.45 newtons. So you can see a newton is actually a really small amount of weight, or a small amount of force. So we're going to talk more about what that looks like later on, but for now, we're really not talking about much here. But again, we measure forces in newtons. So really that's it for today. Again, you can use this force, this spring scale, in any method that you want. The one little piece that we add to it is occasionally I will give you a box, and the box has a little post at the end and has a little hook, and on this side has a little screw, like, oops, like so, like that, and then it has a cable that runs off to the computer. And this is a digital spring scale. And so the digital spring scale has some advantages. we can measure the changes of forces over time. We can measure, we can find the average force over time. We can do lots of different things, and so we will typically try to use those as much as we can. But these work just as well, especially if we're trying to find weights of things, which we'll do often in class. Hopefully that helps. If you have any questions, please let me know. Thanks.